Okay, so one of the big problems with doing case 3 partial fractions is that you're going to end up often with integrals like this, where you have in the numerator a linear term and in the denominator you have your irreducible quadratic. So this is what we're going to look at dealing with today. And the first thing is that we want to remember from the last video, we do have this rule that if we're doing the integral 1 over x squared plus a squared, we proved this is always going to be 1 over a arctan of x over a. And so this is what we're going to rely on. And now, coming back to this original integral, I know that I can split this up into two. And the first integral, I can take the constant 8 outside, leaving me with x divided by x squared plus 9. And if I go to the second integral, I can take the 5 out, and that's going to leave me with just 1 over x squared plus 9. And this is very much why we wanted to split it up. If I look here at this second integral, now we can just use this rule right here. We know that in our case a is going to be equal to 3. And now also looking at the first integral, you recognize that you can do an easy sub there with u equal to x squared plus 9. So we're going to now set up both of those. We have u equal to x squared plus 9, and so du is going to be 2x dx. Bring the constant 2 over to the other side, and now we can sub everything back in. So we have 8 divided by 2 is going to be 4. We have integral 1 over u. And in the second integral, we can leave the 5 alone, but again, remembering how this rule here works, we know that for a equal to 3, this is now going to be 1 over 3 arctan x over 3, and that's the antiderivative for that second integral. So now all that remains is to go back to the first one. We have 1 over u, and we know the antiderivative there will just be a logarithm. So let's get some more room here. With the first integral we have 4, and we have ln absolute value of u. Let's sort of clean up the second one a little bit. We have 5 over 3 arctan of x over 3. Now that we are done integrating, we can also put in the plus c. And then coming back to the first one, we recall that u was x squared plus 9. And so this is our final antiderivative. So you can see, anytime you deal with these irreducible quadratics, the same method is going to apply. You split them up into two. On one, you're going to do just an easy sub. That's right here. And on the other, you're going to do and use this rule. How do you do 1 over x squared plus a squared? And that's it.